This video is about how to produce complex figures using for loops. Let's imagine that we've been asked to draw the following figure as the output of our program. The figure has several different lines of output, and each line has kind of a pattern of characters that appears on the line. The lines have some number of slashes, and then some number of stars, and then some backslashes. So that's kind of the general pattern of the contents of each line. The first line is sort of an exception in that there's no stars here, but you could think of it as following the same pattern, but just having 0 stars there in the middle. The overall way that we usually approach these kind of problems are we look for the repetition and we try to use nested for loops to capture that repetition. Usually what we do is we have an outer for loop that represents each line, so line number 1 through 5 here. And then inside of that outer for loop we have some inner for loops that sort of print sideways to print each of the characters on that line. So normally we shouldn't get started right away with just coding this thing, but just to illustrate kind of the general structure of this program, I'll show you in my editor here. I've written an empty program file to get started. And basically you just want a for loop that represents each line. So let's say each line goes from, the line goes from 1 to 5. And now here we need to figure out how to print the contents of each line. So we said that each line had some slashes and some stars and then some backslashes, but how many is the tricky thing. If we could figure out a pattern, then perhaps we would be able to write the contents in here. But the problem is that the number of these slashes and stars and backslashes is related to what line we're on. So you don't always print the same number of these things. So we need to figure out what's that relationship. What's the relationship between the line number and the number of characters that we're printing? So it's kind of hard to figure that out just by looking at the output or just by playing in the editor. So our suggestion of how to figure that out is to make a little table that relates the two values. So this table here, what I've done is I've counted out the number of these occurrences of each character, and I've written it next to what line we're on. So this is line 1, 2, 3, 4, and 5 here. And what I'm noticing, let's look at these slashes first. If I count these out, there are 16 of the slashes here, and there are 12 slashes here, and 8 and 4, and none of them here. So now the question is, what's the relationship? What's the relationship between 16 and 1 and 12 and 2? Well, the way to figure that out is first you need to figure out when I change the line by 1, when the line increases by 1, what effect does that have on the number of slashes? Well, you can see that from 16 to 12 it goes down by 4, from 12 to 8 it goes down by 4. So the slope, the scale factor connecting the line and the slashes is you take -4 times the line that you're on, right? Each time the line goes up 1, slashes goes down 4. So if you just think about that expression, -4 times line, on line 1 you would get -4 slashes. On line 2 you would get -8 slashes. That's not quite right. But this isn't so far off because all of these numbers are simply off by a fixed amount. So if you look at, if you want this -4 to be a 16 slashes and -8 to be 12 slashes, the adjustment that you have to make to get these numbers into those numbers is that you have to add 20 to each of them. -4 plus 20 makes 16. -8 plus 20 makes 12. And so on. So you can do that for all 5 of these values here. -12 plus 20 makes 8. And that would give us the sequence of numbers that we're looking for. So this expression here is a really key insight that we're gaining from this table. That's the number of slashes that I print as a function of the line number that we're on. So where we use that in our code is, basically what I want to say is, whatever line I'm on, I want to print -4 times that line number plus 20 slashes. So how do I print that many slashes? Well, there's no command to do that in one step, but what you can do is you can make a for loop that repeats that many times that prints a single slash. So you'll say, I'll make a for loop that makes a slash from 1 to that value that we just figured out in the table. And inside the for loop, I will print a single slash character. And to illustrate that that's going to do something good, let's come down here and let's say that after all those slashes, we're going to drop to the next line of output. We're going to end the line. And let's just compile and run that as it is. And you'll see that actually we've already got something pretty useful here. We've got 16 slashes and 12 and 8 and 4 and none here. And so we actually are producing the right number of slashes for this part of the figure. So that's a pretty useful thing we got out of that table there. Let's go back and do the same kind of calculation to figure out how many stars we're going to need. So if you look at the stars here in the table, there are no stars on the first line, and 8 stars here, and 16 stars here, and 24 here, and 32 here. So again, the way to connect that number of stars to the line number is to look at the difference in between each adjacent number to figure out the scale, the slope. So from 0 to 8, it goes up by 8. From 8 to 16, it goes up by 8, and so on. So the expression we're going to end up with starts with 8 times the line number. 8 times line number 1 would be 8. 8 times line number 2 would be 16, like this. These numbers aren't quite right. If you want to make this number into that number, if you want to make this number into that number, you just have to decrease them all. You have to decrease each of them by 8. So 8 minus 8 is 0, 16 minus 8 is 8, and now we're talking. Now we've got the right line number, the right number of stars that we're looking for. So that there, 8 times line minus 8 is the expression that tells how many stars to print. Let's go incorporate that into our code. So here we're going to say that we want to print 8 times line minus 8 stars. So that's pretty simple to translate into code using the same idea from the slashes. Let's make a loop that makes a star from 1 to that number. And inside the loop, we'll print a single star. And the last thing we have on each line is these backslash characters. And if you look at the figure that we're trying to produce, you'll see that the number of backslashes is the same as the number of forward slashes that we had on the left because of the symmetry of the figure. And so actually we don't need to think very much. We can just copy the same expression from the slashes and use it again for the backslashes. -4 times line plus 20. So actually I'm going to go ahead and copy this for loop here and paste it down here. The only difference is that I'm going to print backslashes. And of course, as we learned in the previous chapter, if you print a backslash, that's a special character in strings, so we have to escape it with another backslash. And actually, I think that represents the entire program so far. So if I run this thing, there we go. We've got the 5 lines of the figure all printed out with the proper patterns and proper number of characters and everything. Now, a cynic might say, well, I could have just done 5 println statements to produce this output here. I don't see why I went to all this trouble to use all of these for loops. It seems like it just made the program bigger and more confusing. Well, the idea there is that now that we've captured this repetition, hopefully that would make the program more flexible. So let's talk about how to make this program flexible. In particular, let's talk about how to make it so that the figure can be resized to different scales. So the one that we've already drawn has 5 lines on it. So let's think of that as being the figure at size 5. But let's try to make it so that it would be easy to make the program draw the same figure at a size of 3 with 3 lines on it, or a size of 6 with 6 lines, or any size. Well, how would we do that? One incorrect way to try to do that would be to just simply look for the number 5, and wherever we see a 5, change it into a 3 or a 6. Or something like this. So if you go back to our program here, we've got 5 lines. Maybe we change it into 6 lines and we see if that'll run just that way. Well, you'll see that's not going to do it because the patterns of the characters are different when you change the size to 6. And so it kind of looks right for this part, but it really should be wider, and this bottom part here just doesn't quite look right. So there's a little bit more that we need to do. What we need to do is look at all these different expressions and see what changes we would need to make to those to make the size 6 figure look right. But we still would like this property here where you could change a single value and have the whole figure resize. So for us to achieve that, we're going to use something called a class constant. A class constant is like a variable, but it's got a couple of important differences. One difference is that the value is global, so you can refer to that constant anywhere in your program, as opposed to a variable that's limited in scope to a single method of your program. And the second key aspect of a constant is that its value is only set once. It's only set when you declare the value, and nowhere else can the code change the value. So the syntax for a constant, you write the words public static final followed by the sort of normal syntax for a variable declaration, like type name equals value. In the case of this particular program, we'd like to make a constant for the size of the figure. So what we do is we go back to the program, and up above the main method here, we say we want a public static final integer named, let's call it size. We'll set it to 5 because that's the size of our figure that we're working with. And now the goal is to go to the rest of our code down here and change the appropriate places to say size, so that when we change this value here, all of the code will adapt to that size. So one obvious place we need to do that is here. We need to say that there are this many lines. Whatever the size is, that's how many lines we're going to be printing. But that's not the only change we need to make. As we saw, if we just change this to 6, it just didn't quite look right. So we're probably going to need to change the number of slashes and stars and so forth. But how do you figure out how to do that? Well, the best way to do it is to look at the figure at a couple different sizes and try to figure out the overall pattern. Let's talk about these slashes for a second. So on the 5 lines of the size 5 figure, we computed that the number of slashes here that went down from 16 to 0 using these numbers, we computed that that expression was -4 times the line plus 20. If you do the same kind of calculation for the size 3 figure on the right here, you say, well, there are 8 slashes and then 4 and then 0. So how do I map that into an expression? Well, you can use the same kind of table logic we used a moment ago. 8, 4, 0, they seem to be going down by 4 each time. So the expression has something to do with -4 times the line still. Usually these slopes don't change at different constant sizes. So if I just did -4 times the line number, I would get -4, -8, -12. How would I convert those numbers into these numbers? How do I make a -4 into an 8? How do I make a -12 into a 0? It seems like for each of the 3 numbers, I have to add 12 to get from that number to the desired number. So the expression at a constant size of 3 would be this, -4 times line plus 12. Okay, well, the key insight there is to look at the 2 expressions that we figured out and try to guess what the relation is between those expressions and the size. Well, look at the part that's changed. If we have a size of 5, we add 20. If we have a size of 3, we add 12. And so basically whatever the size is, we're adding 4 times that many. Size times 4 makes 12. 5 times 4 makes 20. So that's how we get our expression. So actually, if we want a general expression that would work for any size, the expression that we're looking for is -4 times the line number plus 4 times the size. That's the expression that we're going to need to use. So we're going to make a change in our code here that says instead of 20, says something like 4 times size. And that's also used here for the number of backslashes, 4 times size instead of 20. So let's also look at the number of stars. That's another important thing. We have to get the number of stars right for our scaling figure. Well, in the size 5, we had 0, 8, 16, 24, 32 stars. So the expression we computed was 8 times the line minus 8, I believe. And now if we look at the same figure at size 3, well, we have 0 stars, 8 stars, 16 stars. And so it looks like those figures are still shifting by 8 each time. So let's say that that's 8 times the line plus something. 8 times line number 1 would be 8. 8 times line number 2 would be 16. And line number 3 would be 24. How do I convert these numbers into these numbers? Well, they're all 8 too large, so I'm going to subtract 8. So the interesting thing there is that actually at size 5 and size 3, the formulas are the same. It doesn't change. You might have thought that this 8 would somehow adjust based on the size here, this -8. But it turns out that it doesn't. So not every expression needs to be adjusted when you change this constant, but you should still do this calculation to see whether you should change it or not. So it looks like in our code here, we don't need to adjust this one at all. It should still work. So if we compile this program with our new changes and we run it, right now the output's not very exciting. We just get the same output that we had before at size 5, but the leap of faith here is hopefully if we change this to a different value like 3, hopefully the adjustments we made will allow the figure to resize gracefully. And there we go. There's the size 3 figure. Let's try it at a different size of 6. And there's the size 6 figure. Looks pretty good as well. And so this is where the real benefit of the for loops come in, is that now the program is very flexible. By changing a single very small portion of the program, we can produce lots of figures at lots of different sizes. So here's one last figure at size 10 to really drive the point home. There it is. And that's our solution to this program.